All right, so let's set up a little job in Hive and compare how long it takes with Tez versus MapReduce. So I've already spun up my Hortonworks sandbox here, and let's go ahead and fire up Ambari. So I'll bring up my browser here and go to 127.0.0.1 and let's log in as admin. Why not? Doesn't really matter. You can log in as Maria Dev for this if you want to. And let's go to the Hive view. All right, so if you've been following along the course, you should have a movie lens database in here that contains a ratings database. So let's take a peek at what's in there. It should look like that. User ID, movie ID, rating, and epoch seconds. And if you do need to go create that, you can take care of that right now. And actually, I'm going to upload the movie title database in here right now as well. So to do that, we just hit the upload table button here. And it's going to be a CSV format. And the delimiter in this file is a pipe character, which is way down the end here, 124. And let's choose the file that it lives in. That's in the u.item file. And we'll call this table names. We're going to load it into the movie lens database. And again, if you don't have a movie lens database yet, just go back to the previous section. All you have to do is in the query window for Hive, type in create database movie lens, semicolon, and that will set it up for you. And you'll also need to import that ratings database as well. Just make sure you can follow the same steps that we're doing right now, except it's going to be the u.data file, and you're going to use tab as the delimiter for that particular file. But again, go back and watch that previous section if you need to catch up on that. Or you can just watch here. All right, so we need to give some column names to the movie lens names database here, and that's going to be the movie underscore ID. We'll call this one name or title, name for our purposes. This is the release date, and we're really not going to use these other fields, so we can just leave them as column whatever. If you're curious, though, it's actually the DVD release date, which it usually doesn't have, the IMDb link, and then the remaining columns are what genres the movie is assigned to, if you're curious about it. So let's go ahead and upload that table, double check everything here, make sure your table name is set, make sure these columns for movie underscore ID and name are exactly as I have them, and the movie lens database is what we're loading it into. All right, our data's in there. If we go back to the query view here and we refresh our database explorer, we should now see a names and a ratings. Very cool. So under names, all of our data's there, and under ratings, all of our data's there. So again, if you need to import ratings from u.data, go ahead and do so. Just make sure that you have these exact column names in there. It should be user underscore ID and movie underscore ID and rating, okay? If you already have it in there under different names, just keep that in mind when we're writing the following query. And actually, if you have the original Hive query from the beginning of the course when we covered Hive, you can use that for this exercise too. It's up to you. Alrighty, so let's issue a little query here in Hive that will actually join some stuff together, do a little bit of, somewhat complex operation here. This is only the 100,000 rating data set in Movie Lens, so it's not really big data, but we're going to give it a big enough job to actually make it sweat a little bit and make it do a little bit of work. So I've already saved off my query here. Let's load that up. I called it Top Movies. All right, so go ahead and hit pause and copy this over if you'd like to, if you need to, or you can just watch. It's up to you. I won't judge. But this is basically the same query that we did back when we were introducing Hive. All it's going to do is figure out the top movie IDs based on how many times each movie was rated, and then it's going to join it with the movie title database, which we've called names, to actually display the movie names alongside their rating counts and sort it by the most popular movies. So I'm not going to get into the details of this query. We've already covered it before. What we want to see here, though, is how quickly it runs in Tez versus MapReduce. So in order to have some control over what engine it just uses Tez by default. Let's go ahead and add a property to that to let us specify what to use. So click on the gear icon here, and we're going to hit Add, and select Hive.execution engine. And from here, we can select Tez, or MR for MapReduce. So let's start with Tez. And then we can go back to the SQL tab here and kick that off and time the results. So I've got a little timer app on my phone here. Kind of do it the hard way. All right, so I'm going to hit execute and then start the clock. Ready? Here we go. And this should just take about 20 seconds or so. So let's twiddle our thumbs a little bit here and just wait for that to finish. 8 seconds, 9 seconds, 10. I'd play the theme music from Jeopardy if I could legally, but sadly there are copyright laws against that sort of a thing. 17, 18, 19, 20, yeah, about 21 seconds. So 21 seconds to finish this query under TES. So, this is just the 100,000 rating data set. It's not that big, so you wouldn't expect it to take too long necessarily. But let's see how long it takes using MapReduce. So to do that, let's go ahead and click the gear again and change the execution engine to MR for MapReduce. And now go back to the SQL tab and we'll run it again. Let me reset my clock and hit the execute button. Start that going. And this is going to take substantially longer. I don't know what to do to kill all the time. I could read a book. I already read that one. I could play with a toy, I guess. What do I got back here? Yeah, here's a replica tricorder I built myself. I'm that much of a nerd. And it's signed by Robert Picardo, the guy who was like the doctor on Voyager. Check it out. It actually works. Cool stuff. This is still running. My gosh. 37, 38 seconds. What else can we do to kill some time here? I could do my taxes. That's not... I don't think you really want to watch that, though. 48 seconds, 49 seconds. Still going. Oh, come on. It's got to be almost done. Well, I play a video game, but my computer's already working here, trying to finish this huge MapReduce job that's only chugging through 100,000 ratings. Hey, it's done! Oh my gosh. Wow, so that took a full 1 minute and 11 seconds on my timer here. So you can see there's a very substantial difference in performance between TES and MapReduce. It's pretty impressive stuff. I mean, it's kind of hard to think of an excuse or reason why you would not use TES when you have the opportunity. It is that much faster. So to recap, the same exact job here, about 20 seconds using TES, a minute and 10 seconds using MapReduce. Let me show you some more stuff about TES here. If you actually go to the views up here, there's actually a TES view you can look at, which is kind of fun. And if we click on that most recent job, you can get some more detail about it. Shows you all the different stages that it had to run through to actually execute. And there's some cool stuff, counters that it encountered. This is really cool, the graphical view. So this is actually showing you the actual directed acyclic graph that TES constructed to complete that job. And you can see it's kind of the same pattern as what we saw in the slides in their examples. So instead of having, separate MapReduce stages that run sequentially, you can see it actually ran some stuff in parallel here. So, while it was reducing the first MapReduce stage, it was already mapping the second one at the same time and combining all the results together in one step in this final reducer that went to our final output. So, this is what TES enables. It just optimizes the workflow of your job under the hood, kind of magically, and just makes things run a whole lot faster. So, there you have it. That's TES. Cool stuff. Thank you to the guys that made it, because it's really made our lives a lot better. All right, let's move on.